So in this problem, we're told a stone is thrown vertically upward with a speed of 24 meters per second. And then A asks us how fast is it moving when it reaches a height of 13 meters. B says how much time is required to reach this height. And C is why are there two answers to B. So before we solve the problem, let's write what's given. So we're told that a stone is thrown vertically upward with a speed of 24 meters per second. So that's telling us that our initial velocity, or v sub 0, is going to be 24 meters per second because it's just thrown at this speed in the beginning. We're also told that or we're not told, but you need to know that when something's thrown upward, the force of gravity is going to be acted upon it. So the force of gravity is minus 9.8 meters per second squared. And so that's going to be acceleration. And then we also know we're asked for A, how fast is it moving when it reaches a height of 13 meters? So its change in y, or delta y, is going to be 13 because it changes 13 meters from our beginning to our endpoint. And then, so what also we need to write down what v is. So because it's asking for A, how fast is it moving when it reaches a height of 13 meters? So basically they're asking for the velocity at this point. So we just described that as v, or the final velocity. So that's what we're trying to find. And so now that we've got all our variables, let's decide which equation to use and solve. So if you look at these, the first three require time, and we're not given the variable for time, right? We're not given a time, so we're not going to use 1 through 3. We're going to have to use 4. So the first three don't work. So let's use the fourth equation. And so that's what we're using. So let's plug in. So v squared, we don't know what v is, so it's just going to be v squared equals v sub 0 squared, so 24 squared, plus 2 times a, which is minus 9.8, times delta y, and it says delta x, but just treat it as delta y. It works the same. So times 13. So v is going to be equal to the square root of this. And so you can plug it in. So it's just going to be the square root of 24 squared plus 2 times minus 9.8 times 13. And so I already went ahead and plugged this in. So it's going to be v equals 17.9, and then velocity is measured in meters per second, right? Or in this case, it's meters per second. So v is going to be 17.9 meters per second. And so that's going to be your answer to A. Let's move on to B. So B says how much time is required to reach this height. So we're trying to solve for time in this one, right? So time, and if we look at our equations, 4 does not contain time. And then if we look, 2 does not contain acceleration. And then the first one does not contain a distance. So that's how we eliminate those, because we're given these variables. We're going to use those to solve. So we're going to be using this one right here. So we have delta, and then it's y, right? So in our case, it's y. It says x, but just treat it as y. So delta y equals v sub 0 times t plus 1/2 times a t squared. And so what we want to do is move the delta y to the other side so we can get it in like a quadratic equation form. So it's going to be 0 equals, and I'm moving this 1/2 a squared out front, or at squared, plus v sub 0 times t, and then minus delta y, right? Then what we want to do is we're trying to get this coefficient out front to be just a number, right? Or we want it to be 1, because then we can actually solve. So if we multiply everything by 2, it's going to get rid of this 1/2. So we're going to get at squared, 0 equals at squared, plus 2 times v sub 0. And then I wrote plus minus, just ignore that. I didn't mean to put that plus, and then it's minus 2 times delta y. And then we want to get rid of this a, right? We just want to have a 1 right there. So if we divide both sides by a, it's going to be 0 equals at squared divided by a is just going to be t squared. So t squared plus 2v sub 0 over a minus 2 times delta y over a. And so now all we got to do is just plug in. So 0 equals, we're trying to solve for t, so we just leave it as t squared plus 2 times v sub 0, which is 24, over a, which is minus 9.8, minus 2 times delta y, which is 13, and then over a, which is minus 9.8 again. And so I forgot the t right here. I said this was a plus, my bad. It's supposed to be a t. I forgot to do that. So these are all t's. And so there's a t right here too. And what you should notice is that this is a quadratic form. I apologize for missing that t, but so you're going to have a t squared, t, and then just a constant, right, which is quadratic form. So if you went ahead and solve this out, you're going to get 0 equals t squared, and then it's going to be minus 4.898t plus 2.653. And then so we have this. So this is a quadratic form. So when you do a quadratic form, you're going to get two different answers. And so you could try and use the quadratic formula to solve this. I would recommend just plugging in your calculator and finding where it crosses 0. Those are going to be your values for t. So I went ahead and did that. So t is going to be equal to 0.620 and 4.28. And so these are both going to be in seconds, right? Because we're using seconds here. And so we have two different values, and C asks us, why are there two different values? So I want you to think about this. We're throwing this rock up, right? And so we're trying to find when it reaches this height, right? So one of these, the first one, right, the smaller second, is just going to be throwing it up, and then it hits it, right? It just hits this. The second one is going to be, or our second value is going to be when it goes up, reaches its maximum height, and then falls back down, and then that amount of time this thing takes is going to be this time. So it's when it goes on the way up and then on the way down. That's the reason we have two different values. And so, yeah, these are going to be your values for t. That's going to be b, right? So, yeah, 0.620, 4.28. And so, yeah, the answer to A would be 17.9. And then so that's how you solve this problem.